All right, so let's move on to our next section. Next, and actually the last section of this chapter. So we are almost there. We are approaching towards the end of this semester. So last section, we are getting there slowly and steady. All right. So this section is about angle measure and segment lengths. Okay. So to me, still it's in reference to a circle. So in reference to a circle, you'll see segments and you'll see angles incorporated with those line segments. Okay, how would that work? So today in this video, I'm just going to talk about one of the case scenarios. So let's say, okay, this is the first case. First case scenario. So let's say you have a circle like this. And inside the circle, you have two line segments. So let me pick a different color. So let's pretend I have two line segments, both intersecting. So what angle goes with what arc? So that's what we're going to talk about. So basically what I see is if these two lines intersect, so exactly at intersection point, I see few angles. So pretend I'm looking for this angle. This is angle number 1, which is on the intersection, which is inside the circle. So now how would you solve for this intersected angle? Okay, basically what we need is just the intercepted arcs correspond to that. So let's say this is A, this is B, this is C, and D. Or let me just say this entire arc is X units long and this is Y units long. So in order to solve for angle 1, so angle 1, measure of angle 1 would be equal to half of sum of X and Y. So basically you just have to add those intercepted arc measures and take half. That would be the angle that's at the intersection point inside the circle. Okay. All right. So let me show you an example. It would make more sense to you. So here's the circle. I see two lines intersecting inside the circle. And I'm looking for this angle, which is angle number 1. And this arc is 90 degrees. The measure of this arc is 90 degrees and measure of this arc is 46 degrees. How would you find the angle at the intersection? So basically it's just adding both arcs and taking half of that. That's how we find the angle. So if I add these two and take half at the end, it's going to be 68 degrees. So that would be the angle in the middle. Okay, all right, so now another example. Let's say here's the circle, two line segments, both intersecting. So pretend this is 70 degrees. This is 40 degrees. Solve for this arc measure. Okay, normally we solve for the intersected angle, which is inside. Now it's the other way around. There are multiple ways you can actually attempt this problem. Some people could do mental math, some people can. I'm going to show you both ways. So some people, if you really want to follow the equation, I'm just going to set it up. So you know, on the left hand side, it's the equation, it's the angle we solve for, which is 40. It's already there. On the other side, it's 1/2, and we add those arcs. We already know one of the arcs, the other one is missing, which is X. So let's just solve this equation. First, I would times it by 2 both sides to get rid of this 1/2. It's 80, 70 plus X. So subtract 70. So X, which is the other arc measure, just going to be 10 degrees. That's one way to deal with. Or mental math. Think about this. Isn't it? This angle, which is inside, is half of sum of two numbers, right? So what I see is half is 40, right? If half is 40, so what two numbers or what number gives you half 40 degrees? Obviously, it's 80, right? So what I see is one of the angle is 70. So how much more do you need to make 80 degrees? So I would say 10 more. Because if I add these two numbers, half would be 40, isn't it? That's just another way. If not, that's okay, totally fine. You can always follow this strategy, set up the equation, and just solve for that. Okay? All right, so this is all. Thank you for watching. Bye-bye.